Hi, Kylie. It's Miss Bromley again. And hi, Miss Halstead, if you're still watching. All right, here we go. We're going to go rather quickly through only 3 of these 4 problems. The first one we're going to look at is number 17. Here it says, given the set, and this business is x such that -2 is less than or equal to x, which is less than 2, where x is an integer. All right, an integer means a positive or negative number, not a fraction or anything crazy. So right here, this tells me that x could be -2, could be -1, could be 0, could be 1, or could be 2. Why don't they just say that? I don't know, Kylie. Good question, but they don't. So all this information says is that these are the 5 possibilities for the value x. What is the solution of -2, parentheses, x minus 5, parentheses, less than 10? So I want to know, oh, there's my cat, sorry, and my son. Okay, I want to know what to put in here so that I get a value less than 10. All right, so we can plug values in, but honestly, because we're looking for several in any case, easiest thing, again, y equals one of our favorite things on this calculator. Oops, I didn't mean to hit graph. I meant to hit y equals and then clear. Okay, so I'm just going to put this part in. So this part is -2, parentheses, the variable x, minus 5, parentheses. Just like that. And I could go to the graph again. What you'll see is it's a line, which is fine. But what we now going to go to is second graph, which is our table. These are the only values I care about, and I want to know when the result will be less than 10. So just by looking at this, obviously this starts at 1 from, no, we're not at, yes, we are at 1 from some other work that we did previous. So obviously 1 has a value less than 10, and so does 2, but I need to find out for these others. So 2 has a value less than 10, looks like it's 6. 1 has a value less than 10. Let's go up. Uh-oh, 0 equals 10. Can't be 0. I go up again, 12. Nope, can't be -1. I go up again. Oh, looks like 14. Nope. So the only possibilities are 1 and 2. So, choice 2. I really think that this is another one that gives us 2 points cushion. All right, this is a pain. I'm going to do it very quickly. If you see something like this that says this crazy thing, recursive formula, which is really kind of tricky, you can skip it. This case, all you need to know is if it says recursive formula, something will say a sub 1 being the first term, and then a sub n being terms coming after, okay? That has to be recursive. So even though these look tempting, they're not the answer because they're not recursive. So this says, if the pattern below continues, which equations is a recursive formula that represents the number of squares in this sequence? All right, so the trick here, design 1 is a sub 1, or the first term, all right? How many squares does that have? Rhetorical question, which means easy question. Yes, it only has 3 squares. Well, I look at these 2 choices. This is the only one that says a sub 1 equals 3. This is an easy one. They aren't always, but that gives you a good way to guess. If I look here, number 19 now, if the original function f of x equals 2x squared minus 1 is shifted to the left, so it goes to the left 3 units, to make the function g of x, which just means another function, which expression would represent g of x? Here's my suggestion. Anytime it talks about shifting, it's talking about the graph. Where does the graph move? Does it move right, left, up, or down? Here's what I would do. Again, big surprise, go to y equals. Let me tell you what, with that y equals key, whoops, it helps you a lot. Nope, nope, nope. Okay, when in doubt, if you hit second, quit, it always takes you to the home screen, no matter what. All right, so y equals, I want to clear that. I want to type this in. 2, then the variable, then my squared key, minus 1. Okay? Now, I'm going to graph that and make sure I can see it on the graph. Okay, I can see it. Now I'm going to go to these choices and I'm going to graph them one at a time. Because remember how fast they graphed on the other problem we did? I won't be able to tell if one of them is shifting because I'm trying to figure out which one is even being graphed. So I'm going to go back to my y equals screen. I'm going to leave the original there, but I'm going to go down to y2 and I'm going to type this in. Let's see, 2 parentheses, the variable, minus 3 parentheses, then I want that to be squared, minus 1. Just like that, I'm going to only graph that one in, and I'm going to graph it. I'm going to watch it. Oh, there it went. Did it move? There's my original. Did it move to the right or the left? It moved right, so I don't want that one. Okay, I'm going to go back to y equals. I'm going to go down to y2. Press clear, so only clear that one out because I still want that original there. All right, so now I'm going to put this one in. 2 parentheses x plus 3 parentheses. And I want to square that, and then I want to subtract 1 and graph. There's my original. Wow, look at that. It moved to the left. Yay, we don't even care about those other two. There's the answer. This is one I definitely think is not a tricky one. If you remember when it talks about shifting, you look at the graph. So choice 2 is our answer here. So now we have 4 cushion points, if you will. So extra points, you know, just in case. Now this one talks about first considering this system, then considering this system of inequalities. When comparing, I mean, there's a lot going on here, and we've only skipped one other so far. I would totally make a guess, pick one here, don't worry about it, and go on. You'll see in the next video that just because we're skipping one here doesn't mean the ones that come after are harder. They're not necessarily. Okay, I'll wait for the next video.